multivariable calculus is similar to what we did in calculus 1, just that this time we are going to apply it to functions that have more than one variable involved. So a lot of the applications are the same, a lot of the concepts are the same. We just need to look at the structure of the function to determine what you would need to work with. So when you're finding the domain of a certain function, so let's say you're looking for the domain of a certain function, maybe f of x and y. You're looking for all values of x and y that would satisfy, or that you can place in the function, and it wouldn't make the function something invalid, right? And if you're looking for the range of the function, so the range of that function, you're looking for all the possible output values you can get, given the input values, the domain that you are placing in there. So I'll give an example. We start with a basic one. If I have my function x plus y, realize that for a function like this, I can put in all real numbers. So that becomes my domain. So I have all real numbers, right, for my domain. And if I want to look at my range, realize that if I put in all real numbers, my output, I can also get all real numbers. So I can put in negative numbers, positive numbers, I can put in fractions, I can put in any kind of real number at all. And at the end of the day, what I'll get is also going to be a real number. So we need to look at the structure of the function, and we need to look at the values that would legally be able to fit into that function for the function to hold. That gives us the domain. And then the possible output values we get, given the input values we consider, that will give us the range, right? So we can take another example, and this time we would use the square root. You know that if you have the square root of a certain function, whatever is within the square root has to be greater than or equal to 0. Because if we have the square root of a negative number, right, when we are looking for when we are dealing with domain and range, we don't consider the complex numbers. So if you have the square root of a negative number, so let's say a negative number, we assume that this is invalid. Okay, so what we want is we want numbers that are from 0 and above when we are dealing with the square root. So we'll take an example. If I have the square root of maybe let's say x plus y, what I'm going to get is that x plus y has to be greater than or equal to 0 for my domain, right? So this is the expression that I'm going to have. X plus y should always be greater than or equal to 0. So I can put in any value of x and y that would ensure that the final output is 0. So if x is negative 2, y can be something like 3. So that's to ensure that it's greater than or equal to 0. But then if there's a case where they are both negative 2, it's not going to hold. So in that case, it would be something that is invalid. So in every situation, x and y, whatever combination we choose, should be greater than or equal to 0. And when we are looking for the range, realize that we are saying x plus y should be greater than or equal to 0. So it means we can start from 0, right? So if I have the square root of 0, the answer I'm going to get is 0. And it's just supposed to be greater than or equal to 0. There's no upper bound to it. So it means that the maximum value we can reach is positive infinity. So if I have the square root of positive infinity, I'm also going to get positive infinity. So it means that my range is going to be from 0 to positive infinity. Sorry, it's supposed to be this bracket, because positive infinity, you can never actually reach positive infinity. So it's supposed to be, sorry, for this bracket. Okay. Another way we can go about this is that if I have when we are dealing with the square root, I can take the expression that is in here. So I know that x plus y is supposed to be greater than or equal to 0, right? And it's definitely going to be less than positive infinity. So if I want to find the square root of this, I'll have to find the square root of everything. So the square root of infinity is just going to be infinity, being greater than my function, which is also going to be greater than or equal to 0. So my range is going to be from 0, for 0 is the lower one, all the way to positive infinity, which is the upper one. So that's how we can go about finding the range of our function. Okay, so we'll take another example. Now, for the next example, we'll try something with natural log. So I can have the natural log of x plus y. When we are dealing with natural log, we know that the values that are valid values that are greater than 0. You can't have the natural log of 0. You can't have the natural log of a negative number. They are not valid. Okay, so we need values that are greater than 0, which means that x plus y, no matter what it is, should be greater than 0. Notice that is not greater than or equal to, is greater than 0. Right, so it means that x plus y should be greater than 0. Now, if you want to find our domain, so this is our domain. If you want to find our range, what we can say is that, once again, 0 is less than x plus y, but then this is also less than positive infinity, right? So we can find natural log of everything. And you realize something, that the natural log of 0 we said was invalid. So what we do in that situation is that, because we can't actually find a natural log of 0, we find a natural log of what happens when we are approaching 0 from above. We can't, remember, we can't approach it from below because then we can't accept negative numbers. So if I have 0, the values below 0 are all negative, the values above 0 are all positive. So if I want to find a natural log of 0, what it is getting close to, the limits, we'll talk about limits as well. So those will make a little bit more sense when we do that. But if I want to find a natural log or lim of a value getting very, very close to 0, I'll put in values very close to 0 and be reducing them gradually, but never actually getting to 0. But later your values will keep increasing exponentially, but you'll be getting a very large negative number. So it will be from negative infinity, being less than or equal to our function, being less than or equal to positive infinity. So this is going to be the range for that function. So when we have natural log, this is what our range is going to be. Unless it's a specialized kind of function where we have something else inside, like maybe natural log of the square root of x plus y. Unless it's something like this, if we have just natural log of something straightforward like x plus y, you can just determine that our range is going to be from negative infinity to positive infinity, because the graph of natural log is this way. So as we keep going closer and closer to 0 on the x-axis, our value gets closer and closer to negative infinity on the y. And as we keep going higher and higher, our value keeps getting closer and closer to positive infinity. So that becomes our range. Okay. So we can take another example. We can take another example. And we are going back to the square root example, but then this time we are going to make it a little bit more interesting. So we have the square root of 16 minus 4x squared minus y squared. So once again, we set up for the domain. Everything within the function of this form has to be greater than or equal to 0, right? So I can say that this is my domain, or I can express it further as 16 being greater than or equal to 4x squared plus y squared, right? Now you realize something over here, that we want this expression to always be greater than or equal to 0, right? And we are saying that 4x squared plus y squared can be less than or equal to 60. So it means that the maximum value that all of this can get to should be 16. So what is going to happen is that the lowest possible value that we would get is going to be 0, because if 4x squared plus y squared was equal to 16, and everything within the square root is going to be 0. So we'll have the square root of 0, which is valid. So we'll have 0 being less than our function. You can say being less than 4x squared, less than or equal to, 4x squared plus y squared. Remember we said that this was also supposed to be less than or equal to 16. So if I want to continue from here to make it like this, what I can do is that I can negate everything, so that I have still 0. If I negate 0, I have 0 being greater than or equal to minus 4x squared minus y squared, and then being minus 16 if I negate everything. Now I still want the function to look like what we have over here. So I'm going to add 16 to everything, so that here I have 16 greater than or equal to 16 minus 4x squared minus y squared greater than or equal to, so 16 minus 16 will give me 0. And now I can find the square root of everything. So 16 minus 4x squared minus y squared, forgive the handwriting, equal to 0. So when we do this, what we are going to have is, let me write it over here. So here we would have 4 being greater than or equal to our function, greater than or equal to 0. Yes, some might argue that's supposed to be plus or minus 4. That's true in some sense, but the one thing we realize that when we are dealing with the domain and range, you don't really consider the negative part of the square root. So you just have to keep that one in mind. Right? So it would be from 0 to 4. That would be our range. Okay, so we'll take another example. Okay, so we can take this example. Let's say we want to find, we can try a trig example. So let's say, okay, so let's say we are doing cos of x plus y, right? When we were dealing with, let's say it was just cos of x, realize that you could put in, if let's say we are taking our values from negative pi all the way to pi, right? Using that notation, so from negative pi all the way to pi, if you are using this notation, realize that we could put in all those values in there. So we're not limited. So in a way, the domain for x was from negative pi all the way to pi, or from 0 to 360. We could put in all the values in there, right? So in the same way, x plus y here would have from 0 x plus y all the way to 360 degrees. We can use this notation if you want to work in degrees. So from 0 all the way to 360 degrees, right? And then when we want to find the range, realize that whatever we put in for cos, our values are always going to be from negative 1 to 1. So for our range, our values are going to be from negative 1 less than or equal to the function less than or equal to 1. So this is going to be the range for cos. Now, if we want to do this for, let's say, the inverse of cos, so arc cos, let's say we have arc, yes, I'm spelling this correctly. So arc cos, so the example we have here is y minus x. It means that now we are doing the inverse. So now what would have been the range for cos becomes a domain for the inverse. So we have negative 1 less than or equal to y minus x less than or equal to 1. And then we'll have our range from 0 to pi, right? So yeah, we'll have our range from 0 to pi. So I think what I did earlier, this was supposed to be 0, this was supposed to be pi. So you can have all values this way, no values this way. Yeah, so we can make it 0 to pi or negative pi to pi because these functions are periodic about those expressions. So I think when we go further, we'll talk about those ones as well. So for our range, we are going to, so for our domain, we'll have it this way from negative 1 all the way to 1. And we can decide to even express it further. So we can decide to make y stand alone. We add x to everything so that we have x minus 1, y, and then maybe x plus 1. So this is also valid. This is also another valid form. Okay, so that's what we would have if we have a trig expression being considered. So another example we can also have, remember we also had situations where we had a quotient. So maybe I have maybe a over b. If you are doing this, you know that b cannot be equal to 0. So if I have an expression like let's say y plus 3 over let's say 4x, right? It means that my 4x cannot be equal to 0, but x can be any other number. So the expression 4x can be any real number. It can be any real number except 0, right? And in that effect, x can be any real number except 0, right? Okay, so that's how we go about questions like this as well. And if you want to find, oh, and sorry, for the domain of y, for y, we are going to have all real numbers because you can place any number in for y. So for the domain, we are going to have two expressions. So we can say that the domain for x and y is going to be all real numbers, right? but we are going to have a case where x cannot be equal to 0. So this is going to be our domain. All knows that then x and y cannot be equal to 0. And realize that for a function like this, if we satisfy these constraints, we don't make x 0. We can put in any number for x and y. And what we'll have is going to be a real number. Okay. So for the range, we are going to have all real numbers, both positive and negative numbers inclusive.